All right, everybody, welcome back. We're going to do 2.3 composition as functions. I'm going to go ahead and skip example number 1. We're going to cover that one in class. So let's go ahead and jump into example number 2. So we're going to take f of x, which is the square root of x, and g of x, x minus 3, and we're going to compose them. So we're going to start with f of g, and I'm just going to put of x. So I prefer to write it like that instead of the little circle. They both mean the same things. So what this is saying is to take the g function, you're going to start on the inside and put it into whatever's on the outside. So we're going to put the g function into the f function. So the f function is this square root, and I'm going to put g in for x. That can't be simplified anymore, so that is f of g of x. Then if we do g of f of x, this time we're going to take the f function and put it into g. So with the g function, that starts with an x. Well, I'm going to replace it with the f of x. That's going to become the square root of x minus 3. That can't be simplified, so that guy is done. The second part, we want to find the domains of each of those. So the domain of the first guy, remember, square roots have to be greater than or equal to 0. So the inside bigger than or equal to 0. X has to be bigger than or equal to 3. So interval notation, 3 to positive infinity. The other domain, still we have a square root, so we're looking at the inside of that square root to be greater than or equal to 0. Nothing we need to simplify, so just 0 to positive infinity. Example number 3, we have f of x and g of x. We're going to find f of g of x. I always rewrite it because now I can see that I'm putting g into f. So I'm going to start writing f. 1 divided by, oops, I see an x. So I'm going to put g of x in for that x. 5 over x minus 2. So I went ahead and I took the g function and I put it into x. Well, we need to simplify this, so we need a common denominator to add or subtract fractions. So this is going to look like 5 over x minus 2x over x. Getting that x as the common denominator there. That's going to become 5 minus 2x. Add or subtract the tops, keep the bottom. So this guy's on the bottom. Now I like to write this out long, so that way I can see what's going to happen when this simplifies. So I like to write it as 1 divided by 5 minus 2x over x. We can't divide fractions, so we're going to keep the first guy, change to multiplication, flip the second guy. 1 times anything is itself, so we're just left with x divided by 5 minus 2x. So that is f of g of x. Now to find his domain, this one has a fraction. In fractions, we can't have 0 on the bottom, so 5 minus 2x cannot equal 0. If we go ahead and solve this, I would subtract 5 from both sides. So negative 2x cannot equal negative 5. Divide by negative 2, x cannot equal positive 5 halves. Writing that in interval notation, we can go negative infinity to 5 halves and 5 halves to positive infinity. All right, so ACC has told us we do not have to cover decomposition. Woohoo! So that is all we're covering. I'm going to save example 1, like I said, to really go more into that function composition. So we'll talk about that in class. Thank you, guys.